Hello everyone, this is Chris. I'm gonna do my article on effectiveness of pedometers and accelerometers based interventions in improving physical activity and health-related outcomes among college students, a systematic review and meta-analysis. This is the second research phase, which is validity and reliability of my topic, which is pedometers. The research area I was focused on is pedometer effectiveness on improving physical activity in college students. Here's the authors and affiliations, which is in China and Malaysia. This is the journal. The journal is called the Digital Health Journal. It has an impact factor of about 3.3 in the last 2 years, which is a little low, but anything over 3 is good. And I just copy and pasted their definition from their website. Basically, a peer-reviewed journal for many people to read. Just a quick introduction to the article. Basically, they found that physical inactivity is a major global health issue affecting over 40% of college students, and they found that pedometer and accelerometer-based interventions (PABI) are popular tools for promoting physical activity. And so basically, this study synthesizes existing evidence to determine if these interventions are truly effective, at least for the college population. The purpose was to conduct a systematic review and meta-analysis examining the effects of PABI on objectively measured physical activity and health-related outcomes in college students. And as a secondary purpose, they wanted to identify which intervention and participant characteristics are most effective through a subgroup analysis. For the methods, they did a systematic review and meta-analysis of randomized controlled trials, and they really focused on RCTs. For data sources, they went into about 5 different major databases ever since February 2022. The participants they were looking for were obviously college students. Intervention styles were pedometer or accelerometer based interventions. The primary outcome they're looking for is objectively measured physical activity. This could be step count or whatever, like number-based outcome they were looking for. And then analysis were pooled effect sizes using random effect models, and it conducted subgroup analysis and sensitivity analysis to ensure robustness. Here's just a flow diagram of how they selected the studies. As you can see, they did about 5 databases, which is like PubMed, Embase, PsycInfo, Web Science, and Cochrane. Very big ones, very well-known ones. And then from here, they had about 1,388, and obviously they removed, they screened wherever there's duplicates or for whatever reason, they're not RCT or they're just not related to the study. And eventually they settled on 9. Here's a quick chart on all the included studies. As you can see, there's about 9 of them from about the past decade or so. See, one's from 2010. They were all either accelerometer or pedometers, either smartphone apps or not. As you can see, there's very small sample sizes for a lot of these studies, but they were all randomized controlled trials, and they were all based off of college students. So something interesting they did was determining the biases in the studies. As you can see, they were looking for selection bias, performance bias, detection bias, attrition bias, reporting bias, all the biases that are very common. And they found that most of them were low risk of bias or unclear risk of bias, and not really many higher risk of bias, which means that many of the studies were really well done originally, but that's about it. I just thought this was interesting. For the results of the article, for the primary outcome, they found that pedometer and accelerometer based interventions significantly improved physical activity when compared to the control group. The health outcome was that it had significant weight loss and BMI reduction, but interesting enough, they didn't find any body fat percentage decrease or any motivation in like pretty much exercising by yourself. For the subgroup analysis, which is what I was most interested in, was if you remember, my topic is pedometers, and they found that pedometer-based interventions were significantly effective, and accelerometer-based ones were not, which shows that pedometers were either more valid or reliable than at least accelerometers. Something interesting was interventions using theory. An example would be like a social cognitive theory, were more effective when done with these interventions. Interventions targeting general students, not just the inactive ones, showed larger effects, and step count was the most responsive outcome. For robustness, for the sensitivity analysis, they found that a positive result was stable and not dependent on any single study. And for the funnel plot, it showed no strong evidence of publication bias. So here is one of the charts they showed. It's probably the best one they had, where they showed that, as you can see at the bottom, They labeled it a little differently from what I'm usually used to, but they labeled it favored to one side. As you see, a lot of the studies favored interventions, which means they prefer like pedometers and accelerometers, whichever it were, showed more either like physical activity or weight loss or whatever they were looking for. Um, and they also had high heterogeneity, which is about 70% okay, but it was still good to show that a lot of these tests were consistent, and none of them really favored the control. Um, in case you got your eyes got a little confused, the red line is their deviation, their standard deviation, which shows that overall it was effective at increasing physical activity, and the black line is the zero, which shows either no effectiveness at all. This figure is a little confusing, but basically this was one to show the different health outcomes, which is, if you remember, it was the one on weight reduction and BMI reduction, and it also was to show that there was no reduction in body fat, and the self-efficacy for actually motivating yourself to exercise by yourself also didn't increase. This is basically what this graph is showing. I didn't really like this table at all because one, heterogeneity is really weak, so a lot of it was like it's just not consistent across anything. They did show that their their standard mean deviations were more in favor of interventions, except the last one at the bottom. But even then, the individual ones didn't really show much, other than one of them at the top. So this is the subgroup analysis of physical activity at post-intervention table, which is the one I was most interested in. They basically took all 9 studies and split them up into smaller categories, and basically see which one was the most effective. As you can see, for the outcomes, the step, if you're only measuring step outcome, it was the most effective. You want to focus on the right side with the SMD and 95% confidence interval. The p-value less than 0.05 is what we're looking for. For the participants, general was the best, with pretty low heterogeneity, but it still showed the best results. For theory, if you were to focus on a certain type of theory, in case they were given social cognitive theory as an example, then you had a better result than just going into it without much thought. Low heterogeneity though, which is what the middle column is showing. And developed regions show the best at the 0.01 p-value. And then the one I was most focused on, interventions. As you can see, pedometers were the best type of intervention strategy at way more than accelerometers. In fact, accelerometers had a 0% heterogeneity value, which is surprisingly really bad. But as you can see, no matter where you looked, overall physical activity was just increased. Here's something else I talked about in the results. Basically, on the left, the funnel plot is basically showing the bias, and basically wanting to show that none of these are very biased, and they're very close to their effect size. Basically, what you want in this plot is you want a reverse funnel shape as they're kind of drawn here. You do want to reverse Venn lines, but you can have a little bit of deviation. Basically showing you want them low, and also you want them close. Basically, you want them close to their actual real effect size, showing that none of them was very out of place with how the biases went. On the right, this is a sensitivity analysis. Basically, what this is showing that no one study was very overpowering. Basically, you will look at that study. If you took out that study to see if there's any major shifts in the standard deviation and how their analysis went, and as you can see, none of it was significant, which means no one study was like the overarching reason for the outcome. So in conclusion, PABI, pedometer and accelerometer-based interventions, particularly pedometer-based in theory-driven programs, are effective strategy for increasing physical activity and promoting weight loss among college students. Connecting to other research phases, this is obviously phase 1, benefits of physical activity, weight loss. Phase 4, factors that influence physical activity, in this case, having a device. Phase 5, effective interventions to promote physical activity, in my case is pedometer interventions. Political practical applications, For university health promotion, this is basically to implement structured pedometer programs supported by behavior theory to potentially help these sedentary lives of college students more. For practitioners, focus on increasing daily step count as a simple, effective metric that we've all heard about before. And then programs can be effectively offered to the general student body, and not just those identified as like at risk, or inactive in this study's case. For strength of the study, it had really high validity. Included only randomized controlled trials with objectively measured physical activity data, in which case, your step count or whatever they decided. They didn't have subjective self-reported data, which makes it a little more reliable. On robust methodologies, adhered to the PRISMA Cochrane guidelines. They performed sensitivity analysis and investigated heterogeneity. Pretty much went the whole 9 yards. And then it had like very actionable insights with like subgroup analysis providing more clear guidance on what specifically in all the studies were the most effective. Some weaknesses, as I said before, really small sample sizes, and there's only 9 studies included, limiting statistical power. It was a very short-term focus. Could not robustly assess the long-term maintenance of physical activity changes using these devices. And then heterogeneity, a lot of it was moderate, some moderate statistical variation between studies remained, even after the subgroup analysis, as you saw some of them were like 0, very low, very, very low. Future studies, for the author's take, he basically suggested that future studies should investigate whether the positive effects of pedometer and accelerometer-based intervention on physical activity and weight are maintained over time, longevity. He also said that there's a need to further explore the characteristics and effectiveness of combined intervention models. This means studying how pedometers and accelerometers can be best integrated with other strategies like counseling, social support, or personalized feedback, to maximize impact. And then he also said more research is needed to understand the underlying mechanisms. Since the study only did not find like a significant improvement in exercise self-efficacy, getting people to exercise by themselves, future work should investigate whether specific behavior or psychological factors that are actually driving the positive changes in behavior. And from my own personal take, I think having like a different population other than college students, or seeing if other environmental factors can affect the outcome, such as income or race and ethnicity, and not obviously not just focusing on inactive college students. And then longitudinal study, as said by the author. Thank you for listening.